So this is 2.7, 2.6, 2.7, our rational stuff from yesterday, asymptotes and all that. You guys are going to have a quiz next Friday. Probably, I don't know, 6, 7 questions. The first 5 or 6 will give you a rational and say, find the domain. The next one will say, what are the vertical, horizontal asymptotes? The next one might say, what are the holes? Then every version will have some sort of a question that gives you the rational, and you have to find everything and then graph it. All right? It's kind of like one of those problems that we had with our, remember our quadratics where I gave you the equation and then you had to find everything, the vertex, all this stuff, and then graph it. Same kind of concept. So when we do this, and I'll tell you what you're trying to find, but go ahead and write this down. You guys are going to find, hang on. We're going to find, I think, doesn't matter what order you do it in, we just got to find it all. Domain. What goes with domain? What kind of goes hand in hand with domain?
Range.
Yes, but we're not doing range in this one. What yesterday from our cheat sheet? Your cheat sheet should be right next to you. What goes next? Vertical asymptotes. Good. Then we can find our horizontal asymptotes. Then we can find if there's any slant asymptotes. We need to find X-intercepts, Y-intercepts, holes. Did I forget anything?
On the quiz and I'll be written out.
Yeah, I'll write it. I'll write it for you guys. But you have to find all this stuff, and then you have to be able to graph. Now, the graphing part is not difficult. What's going to be difficult for you guys, and it's just because it's a little extra work, is you have to test points and plug in numbers. So we're going to do these two together, and we'll talk about it. So get your cheat sheet with you. Get your cheat sheet ready so you guys can see. I'm going to minimize this a little bit so we can do some work. How do you find the domain? Remind me again how to find domain.
Oh, you equal the denominator.
Okay, denominator not equal to 0, right? So x minus 2 cannot be 0. I know a lot of you can do this in your head, but this is you showing me your work so you understand where you're looking and what you're doing. So you would tell me that x cannot be what number? 2. So my domain is everything in the entire world except for 2. How would I write that? Negative infinity to 2, union 2 to infinity, right? There's no brackets because it does not include 2. At 2, it becomes undefined. So if I found out that my domain is anything in the world but 2, where is my vertical asymptote? At x equals what? At x equals 2, right? Your domain and your vertical asymptote go hand in hand. Everybody with me? Okay, so now let's find our horizontal asymptotes. Well, look at your cheat sheet. Remind me again, how do you find the horizontal asymptote? We compare the degree of the numerator to the degree of the denominator. So look at your function. What is the degree of the numerator? 1. What's the degree of the denominator? 1 equals 1. If the numerator degree is equal to the denominator degree, our horizontal asymptote is at y equals what? The leading coefficient of the numerator over the leading coefficient of the denominator. So it's 5 over 1, which is the same as what? 5. Okay, so you would say y equals 5. Do you guys notice how I'm putting x equals and y equals? Very important. If you want to go ahead now and graph your asymptotes, you absolutely can. All right, let's watch how we do our asymptotes. Asymptotes are not solid lines. They're dotted lines. They're just a boundary that you get close to. You cannot cross a vertical asymptote. Your graph may cross the horizontal one, but it will not cross a vertical asymptote. So I have a vertical asymptote at x equals 2. So I'm going to do a little dotted line right here at x equals 2. Is everybody with me? Okay. Where is my horizontal asymptote? Y equals 5. So 1, 2, 3, 4. I'm going to go up here to 5. All right, everybody okay? All right, do you see here I have regions of my graph? There's one here, there's one here, there's one here, there's one here, right? All right, we're going to test points in those different regions to figure out where our graph exists. We'll talk about that in a second. So slant asymptote. Look at your cheat sheet. Tell me how you find a slant asymptote. Long division. Okay, so I'm going to say x minus 2 into 5x. How do we write our answer? Our slant asymptote needs to be written in what? What kind of form? What is it?
With no remainder.
No remainder, good. It should be in y equals mx plus b. You should have a slope and a y-intercept. So if I say first term into first term, x goes into 5x how many times?
5.
All right, is there anything left over? Right, if I multiply, I go like this, I get 5x, and then I have minus 10, and then I bring down the 10. Negative 10 is my what? Remainder. So do you guys agree with me that this says y equals 5?
Yeah.
Is that a slanted line?
No.
What is y equals 5? What is y equals 5? It's our horizontal asymptote. So does this have any slant asymptotes? No. You'll only have slant asymptote when the degree of the numerator is bigger than the denominator. Do you see how these are the same? When you do your long division, it's just going to go into it. It's going to just be one of the asymptotes. But all right, let's talk about X-intercepts. Look at your cheat sheet. How do you find X-intercepts? Set the numerator what? Equal to 0. Okay, so I'm going to say 5x equals 0. Well, divide both sides by 5. What does x equal? What's 0 divided by 5? 0. So my x-intercept is going to be at 0, 0. That means my graph is going to go through that. You can put that on your graph right there, 0, 0. How do you find the y-intercept? What does your cheat sheet say to do? Plug in 0 for the entire function, right? So my function is be 5 times 0 over 0 minus 2. Well, what's 5 times 0? 0 over negative 2. What's my y-intercept? When I plug in 0, what do I get out? 0, okay. Happens to be the same spot, no biggie. And then holes. How do we find holes? Your cheat sheet should be right next to you, sitting. You should have put it right on this problem, so you're just looking and looking and looking. Brett, tell me, how do I find a hole? Oh, Brett, your voice has changed. You factor the numerator and the denominator. So if I have 5x over x minus 2, can I factor anything? Or is it already completely factored? I cannot factor anything else. It's completely factored. Is there anything on top and bottom that's exactly the same that's going to cross out? No. So your answer for holes would be none. So individually, guys, if you were asked any of these questions, just individually, if they said to you, tell me the vertical asymptotes, that's how you would answer your question. You would set your denominator equal to 0 and then say x equals 2. If it said slant asymptote, you would show me that you tried to do the long division, how it worked out, and then you would say none. Do you guys understand that? Okay, so now we have to figure out what our graph looks like. Remember, our graph, the parent function of our graph was something like this, right? Like those little boomerangs. Yes? So your graph is going to resemble that, but you have to figure out where it exists. So what you're going to do is we are going to test points on our region to the left and to the right of your vertical asymptote. So pick a point. My vertical asymptote is at x equals 2. Pick a point to the left of 2. 1. Okay, let's plug in 1. Let's plug in 1 into my function. If I plug in 1, let's see what I get out. 1 comma what? Well, my function is 5x over x minus 2, right? Yes, agreed, guys? Okay, so 5 times 1 over 1 minus 2. What's 5 times 1? 5 over 1 minus 2 is negative 1. So when I plug in 1, I get out negative 5. You guys agree? So when I plug in 1, I get out 1, 2, 3, 4, 5, negative 5 right there. All right, now let's pick something way over here just to see where that point would lie. Pick something over there. Negative 7, okay? So now I'm going to plug in negative 7. 5 times negative 7 over negative 7 minus 2. Agreed? Okay, so negative 35 over what? Negative 9. What is that about? 9 goes into 35 how many times? Yeah, it does. 9 goes into 35 about how many times?
3.
What's 9 times 4? 36. So 3 and a bit. We could say 3-ish. You guys agree? Positive? So I go to negative 7. 1, 2, 3, 4, 5, 6, 7. And I go up 1, 2, 3 and a bit. I just need an approximation. Now you should connect your dots in a nice smooth curve, like a boomerang looking thing that gets close to your vertical asymptote and your horizontal but doesn't cross it. So this side of your graph is going to look something like this. Everybody see that? You need to pick a few points. Somebody could have done negative 6. Somebody could, but you need to pick a few points so you can get a general idea of what your curve looks like. Now we're going to pick some points to the right of your vertical asymptote. My vertical asymptote is at x equals 2, so pick something else. Pick something bigger than 2.
4.
Okay, let's plug in 4. When I plug in 4 into my function, what do I get? So I have 5 times 4 over 4 minus 2, right? What's 5 times 4? 20 over 4 minus 2 is? So when I plug in 4, I get out what number? 10. So I go over 4, 1, 2, 3, 4, and I go up 10. 1, 2, 3, 4, 5, 6, 7. It's way up here somewhere, right? Okay. So now pick something a little further out. We just want to see kind of what our shape is, how far down our curve goes. Pick something a little further out than 4. 8, okay. Let's do 8. 5 times 8 over 8 minus 2. What's 5 times 8? 40. Over 8 minus 2 is 6. What is that about? I don't need anything real specific, but
6-ish.
it's 6-ish. Okay, that's fine. 6-ish. So I go over 8. 1, 2, 3, 4, 5, 6, 7, 8, and up 6-ish. 1, 2, 3, 4, 5, 6-ish. So my curve is going to be like this. And there is the graph of your rational function that we just did. You're going to identify all this stuff. And then once you do, you're going to pick points to see if your boomerangs are in the top left, top right. Or if they're top left, bottom right. Or if they're bottom left, top right. You know, whatever. You got to have to figure out where they are. You can't just randomly draw them and be like, oh, I think it's here. You have to test points, plug in points, and then you can figure out where your curve is. Yes, sir. All right, we're going to do the same thing here, but how is this a little different? There, do you see squared? The first one that we did, both of them were to the first power. How many vertical asymptotes did I have when the denominator was to the first power?
2.
I had 1. How many vertical asymptotes am I going to have here? 2. Right, I have x squared. Let's find the domain. All right, let's go through our list. Let's find the domain. How do you find the domain of a function? A rational function, I'm sorry. Set the denominator. Not equal to 0. So x squared minus 25 cannot be 0. X squared cannot be 25. Square root. X cannot be what numbers?
5.
What kind of 5s? Positive and negative. So my domain is going to be, tell me, negative infinity to? Negative 5. Good. Union. 5, negative 5 to 5. Union 5 to infinity. Good. So what are my vertical asymptotes? X equals plus and minus 5. So if you want to go ahead and put those on your graph, go ahead. So I go 1, 2, 3, 4, 5 to the right. And I go 1, 2, 3, 4, 5 to the left. Now, what do you guys notice here? What did we just say? The first problem had how many asymptotes? 1. Now I have how many? So my graph's going to be broken up into 6 regions instead of just 4. So we just have to test a few extra points. You'll see in a second. Now that we found our domain and our vertical asymptote, let's find our horizontal asymptotes. Horizontal asymptotes. Remind me again how we find horizontal asymptote. Look at your cheat sheet. Horizontal asymptote. Compare the numerator to the denominator. So my numerator degree is 2. My denominator degree is 2. 2 what 2? 2 equals 2. So when the numerator degree and the denominator degree are the same, what do you do with the leading coefficients? You put it over each other. So I have a horizontal asymptote at y equals 2. At y equals. If you don't write x and y, I'm marking it wrong. Not just partial credit. Wrong. You guys have to tell me. So now, do you guys see I have 1, 2, 3, 4, 5, 6 regions. Right? Everybody see that? You can almost count it as 8 because the middle ones are cut by the y-axis, but we'll talk about that in a second. All right, slant asymptotes. Remind me again, look at your cheat sheet. How do you find slant asymptotes? Long division. So I'm going to say x squared minus x minus 25 into what? 2x squared? Okay. So first term into first term. Goes 2 times. So 2 times x is 2x squared. And then I have all this other stuff, right? Minus x, minus 50. Well, when I bring those down, what are those? Remainders. So those don't matter. So my slant asymptote is y equals 2, which is our horizontal asymptote. So my answer is none. We don't have to worry about that. We'll do some tomorrow or Tuesday that have slant asymptotes so you guys can see.
Wait, there's no slant asymptote?
There's no slant asymptote.
When there's a remainder?
No, because your slant asymptote is y equals mx plus b, right? So the remainder doesn't matter. So this is the only thing we have. So we have y equals 2, which is what it's our horizontal asymptote.
Okay.
Yes, sir.
When there's no mx.
All right, let's go ahead and find our x and y intercepts. We need to plot those on the graph. How do you find x-intercept? What's your cheat sheet say to do? X-intercept. Set the numerator equal to 0. So 2x squared equals 0. Divide both sides by 2. X squared equals 0. Now what? Take the square root. What's x equal? 0. We write our x-intercept, guys, as an ordered pair. So my x-intercept is 0, 0. Put it on the graph. It's not always 0, 0. These just 2 examples work out that way, but tomorrow they won't. How do you find your y-intercept? F of 0. You plug in 0. So I'm going to say 2 times 0 squared minus 0 squared minus 25. What's 2 times 0 squared? 0. Over, what's 0 minus 25? Negative 25. What's 0 divided by negative 25? 0. So my x-intercept is at, my y-intercept is at 0, 0. And remind me again how to find the holes. How do you find holes? Factor the numerator and the denominator. And cross out anything they have in common. So if I fully factor this, I have 2x squared over x plus 5, x minus 5, right? Is anything exactly the same on the top and bottom that I can cross out? So my holes would be none. Now we need to figure out what our function looks like. When you guys have 2 asymptotes that are vertical, do you see this? Right? Your graph is gonna look a variety of ways. It could be like this. The outside ones are like this, and then the inside one's like this. It could be that the inside one is like this. It could be that the inside one is like this. One of the boomerangs is over here. Something like that. You have to make sure, that's why we check points, because we have to see where our function exists. And then we connect in a nice smooth curve. So let's pick something. Let's pick a point to the left. Let's pick 2 points. Let's pick 2 points to the left over here of my first vertical asymptote. -8. Don't do ones right next to each other. How about like -6, -8? We okay with that? Okay, so I'm going to do -6 and then -8. We're just going to see where those points exist. So my function is 2x squared, so 2 times -6 squared over -6 squared minus 25, right? Yes, guys? Okay, so -6 squared is 36 times 2 is 72 over 36 minus 25.
19. 11.
Okay, so 72 divided by 11 is about how much? 6-ish, right? So 6-ish. So when I plug in -6, I get out 6-ish. So on my graph, I'm going to go over -6, and then I'm going to go up 6-ish. 1, 2, 3, 4, 5-ish. Everybody with me? All right, now, like I just said, Camila said do -6, -7. Pick points that are a little spaced out. So let's do -8, -9, something like that. Let's do -8. So 2 times -8 squared over -8 squared minus 25. -8 squared is 64. 64 times 2 is 128, thank you. Divided by, what's 64 minus 25?
39.
Don't guess, guys. Write it down. You guys make silly mistakes on your test and quiz about this. What's 64 minus 25?
Yeah, 39.
Okay, I just wanted you to make sure. All right, so 128. Where is that about? How many times is 39 about going to 128? Think about 40 into 130. What is that about? 40 into 120. What is it about? You guys are going to have to do this on your quiz, so I'm not going to do this for you. What is it? 3-ish. Okay, 3-ish. So if I go over -8 and I go up 1, 2, 3-ish, do you see where your little boomerang is going to exist? That top left-hand corner. Everybody see that? Yes or no? So you can connect right here. You can say, okay, my boomerang is going to be right here. That means it's not going to be down there. If it is in the top one, it's not in the bottom one. So let's now move into the middle section. Do you see how this middle section is cut by the y-axis? Yeah. I would pick something on this side of your y-axis, and then I'd pick a point on this side. And let's see what our graph looks like. So pick something in between -5 and 0. -3, that's a good one. So I'm going to plug in -3 and see what I get out. So I have 2 times -3 squared over -3 squared minus 25. Well, what's -3 squared? 9, and 9 times 2 is 18. Over, what's 9 minus 25? Negative, what is it? 16. Okay. Where is -18 How many times can 16 go into 18? 1-ish. What kind of 1-ish? -1-ish. We're just getting an idea. So at -3, I'm at -1-ish. I'm below. You guys see that? I'm below the horizontal asymptote. Now pick something to the right. Okay, you want to do +3? That's fine. So let's do +3. So I have 2 times 3 squared over 3 squared minus 25. Well, what's 3 squared? 8. So 9 times 2 is 18 over 3 squared is 9 minus 25. -16. Oh, I got the same thing. That's all right. So it's still -1-ish, right? So I go to 3. 1, 2, 3, and I'm at where? -1-ish. Do you guys see how you just created what your little curve would look like? If you plugged in +3 and you got something up here, then your middle graph would look like that, right? But it doesn't. When you plugged in -3, you kind of got a mirror image of the other one. So your curve now occurs here, like this.
It has to cross through the X and Y-intercept right there.
Yes. But sometimes it looks like a snake and goes like bottom left to the top right. Sometimes it looks like a parabola. Could be positive or negative. That's why you have to test points on the left and the right-hand side to make sure. And now, guys, let's figure out where our boomerang exists. Is it going to be in the top right corner or is it going to be in the bottom right corner? Pick 2 points to the right of your vertical asymptote.
9.
Okay, and what else?
6.
6 and 9. Okay, fine. So I'm going to plug in 6 and see what I get out. I'm going to plug in 9 and see what I get out. So I plug in 6. I have 2 times 6 squared over 6 squared minus 25, right? What's 6 squared?
36.
Times 2. 72 over 6 squared is 36 minus 25.
No. 11.
Which one is it? 9 or 11?
11.
Okay. How many times does 11 go into 72?
About 6 times.
About 6 times. 6-ish. All right. So I'm going to go over 6 and then up 6. 1, 2, 3, 4, 5, 6. Right now, you guys told me, where does my boomerang exist? Is it going to be in the top right or the bottom right? Top. Right? It's up here. Let's try 9, though. Let's just see so we make sure we connect our curve pretty. 2 times 9 squared over 9 squared minus 25. Well, 9 squared is 81. And 81 times 2 is? Crickets. It's 81 times 2. 162. Okay. Over 9 squared is? 81 minus 25.
56.
56.
See.
81 minus 25. 56. Okay, good. Good for you. Good for you. So when I plug in 9, how many times does 56 go into 162?
3-ish? Not.
How about like 2-ish?
2-ish.
2-ish, right? 2-ish. So I go over 9, and it's 2-ish. It's just above our horizontal asymptote, correct? And now we just connect our nice smooth curve. We get close to our asymptotes, but don't touch. And there is the graph of your rational function. Now, the more we do this, the quicker you guys will get at it, I promise. But what takes the longest amount of time? That. The longest amount of time is the 6th, 7th grade plugging in X values and getting out Y values. That's what takes the longest amount of time. Yes, sir.
Do we have to plug also the ones that are like,
No.
on top?
Because you know, like with what you plugged in, you can tell the shape of your curve.
Oh, all right.
So this would be what the answer is that I'm looking for on your quiz. You're going to list out all your domain, blah, 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 blah. I'll have it all listed out for you. But this is what I'm looking at, that you graphed correctly, that your asymptotes are correct, that your actual pieces of your rational function are where they should be, where they're supposed to be. You'll have one of those on a quiz. I'm not going to give you like 4. That would take forever. But we are going, hold on one sec. We're going to practice tomorrow, Tuesday, and Thursday. I have a ton of these. I'm going to say find everything. And the more we do it, the easier this will get, the more fluid this becomes. Because you guys will not have your little cheat sheet on your quiz. You have to know. The one thing that sticks out, usually when I say, how do you find slant asymptote? You guys all say, slant asymptote. Long division. For some reason, that sticks in our mind. The other ones are a little like, ooh, I gotta look. Just make sure you have this right next to you, and we're just gonna keep referring back to it. Yes, sir.
When you're asking us the graph and we gotta like